Next we have James Simmons. This is going to be the correct James Simmons with the correct talk, with the correct bio. There's no reference to 2013 here, so. James Simmons has been involved in Linux kernel development since the late 90s. Over his career, he's contributed to Linux kernel to support everything from small embedded devices to supercomputers. Shortly after joining ORNL in 2008, James got involved in Lustre and has become the largest contributor to Lustre outside of Intel. Right on. Let's see if I can figure out. I mean, you know, I promised you guys the right talk this time. Here it comes. Come on, lucky 7. There we go. Ladies and gentlemen, James Simmons, maniac person.
So I wanted to cover a topic to introduce people out there to what's the changes that are going on right now. Everybody here has probably done some kind of dump. Their Lustre system craps out and they don't know what to do. So they collect the logs and they send it out. And we've had these tools and you kind of look at them and you say, I don't know what this means. Let's just send them off to Intel to figure it out. So this is more of to show you how in the future this will change and allow you about more flexibility. So this talk is more from a system administration point of view than like I have a developer day slides that I'd like to we'll make public to show you how to actually use this utilities. So currently, as I was discussing, we have the lctl method of profiling and trying to figure out what's going on. So this was, the reason we have this is this was developed long before the Linux kernel had any kind of standardization for profiling of any kind. It's gone through many iterations, several projects have come up over time, but lctl has been here to stay. So the way it works, you can do commands to do a dump, or you can run it as a debug daemon to collect the data. I'm sure that most of you here are familiar with having this. So the magic behind this is that's hidden is lctl has a set param that sets the debugging levels in that. So the way it does it is it sets a module parameter on libcfs, and it's based on categories and subsystems. So you can only do debug. Most people are familiar with doing things like lctl debug for LFSCK or security stuff and things like that. So it's in categories. The other one is you can control which subsystems, like the MGS or LLite, you can filter it. And it's all done by that command. Everybody's done that. So there are limitations to this. The main driving force initially for this was that upstream does not like our debugging system, and we reinvented the wheel, and they want us to use all their systems. It lacks advanced filtering things. You can't really filter and control. It's like a heavy hammer. It dumps everything. You can't control like when to print out a debug statement. It just prints out anytime. There's not any conditionals, like if it reaches a certain amount of times executed or anything like that. It scales, but doesn't scale really well. I've had the instance where we've had our servers bork, and then it would say can't allocate pages, and it would just overflow, and we would lose a lot of data. And actually, from my personal experience sometimes, I've actually seen where I try to use the system to debug stuff, and the debug info would sometimes show up, and for some reason wouldn't show up sometimes when I was debugging. I don't know why, but it did this, and it was very strange. It wasn't often, but it would happen, and I couldn't collect stuff, even though I put debug statements in there. And the other limitation is it's very Lustre specific, and it's internal to the Lustre code itself, where modern things, modern utilities, you can get an entire stack profile from user land applications all the way down to the device. And the other thing, and today the tools that we have can do everything that the utilities Lustre uses today, and even more. So, no, I'm not into ponies, but ponycorns were decided as the mascot for a lot of these projects. So these are all the tracing projects that have been developed over the years for Lustre. For Linux in general. So out of those, a lot of people are probably familiar with System Tap. I know someone here talked about it with me, and dtrace, which is the originator of the ponies. And so out of those, the three that have been integrated and accepted is ftrace, perf events, and eBPF. So I have a question, how many people have used perf here? That's expected. How many have ever used ftrace? That's not too bad, actually. A lot of people don't. It's one of those things that it was developed, no one ever used. And I'm just really curious, because this is like the newest, latest stuff, is the ePF. Anybody ever played with it? No, not yet. Well, that's coming in the future. So I wanted to go over using these modern tools. So what does the kernel support? So we can do regular tracing events in kernel space. Also with 3.5 plus kernels, you can do userland probes, static traces in them. You can do ftrace and use like trace command and perf. And in newer kernels, ftrace is being integrated into perf, so you don't need the trace command anymore. Though I hope they integrate, because trace command, you can actually channel your logs over the network, and I hope perf integrates that. And of course, you have ePPF, but you need a 4.9 plus kernel. With BBC tools is the main way to use that. The other thing is if you want to integrate and get a profile of the userland stack and how it's being called into Lustre, you have dwarf support. So in older platforms, you have libonline. In newer distributions, you have libwdw, which is much more better performance. So, and I give an example of like what you can see. If you run that command, you will see with DD, you would see all the way from DD and execution in the userland code, all the way down through the stack in Lustre, what's going on. So there's also the dwarf 2 utilities. This is more for developers. To develop, you need a debug kernel for this. There's utilities like PA whole, which allows you to see the actual stack structure and where it's offsetted. And you'll need that if you want to do advanced probing of data. And to show you the power of perf, I threw this in. It's not really Lustre related, but there's a project called AutoFDO that's used with GCC. And what it does is it builds your application. And if you have this set up, perf will run on your application, use the output of the application, and rebuild your application to be optimized more. So here are some of the things that you will run into if you want to do this setup. Perf is limited. It's heavily castrated on many systems because it could do a lot more than what it does. Most people use perf for perf top. And there's a question, how many people have used something besides perf top? That's not a developer. Okay, I thought so. It's much more limited. So perf has a lot of abilities and because of this, and most people use it in this way, the perf that's sent, one of the showstoppers is that you can't see the userland stuff, so it's not automatically built with libonline. So if you want to get a complete stack profile from userland down, you're not going to get it. And there's other tweaks too that it combines with the lib, NUMA, control libraries, and things like that. So when you install this, you're going to see you might have some problems. Like you won't see the indentation of the perf output, so you won't. That's because you're either missing the libonline stuff. So the advantage of libonline is if you don't want to install it, you have to rebuild everything with fno-op frame pointer. Has anyone ever played with that flag? Okay. So once upon a time in the old days, there was only a handful of registers. And this was designed to prevent that. So because there were so few, you would lose information about like where the stack pointer is and the IP pointer. So over time, GCC developed this so that you could actually not worry about the pointers and you could get all the information. So there's a little bit of overhead to do that, but it's trivial. But in order to get around that, but that requires rebuilding all your applications. So the way around that is you install libonline or libdw, and it will work outside of that because, well, face it, our users are not going to rebuild with a new flag, and you might not be using the GCC compiler, things like that. Other issues is you won't see the debug symbol, so you do your dump, and you see just hexadecimal numbers listed, and you're like, what does this mean? So what you need, you're missing the debug info packages. So for things like RHEL, you have to set up a separate repo, and it's quite a challenge. It's actually quite a mess for that, so that way you can install things like DD, debug info. There's a special repo for that. You might still need to rebuild in that case, like if you're using custom apps to see what's going on. Other gotchas when doing this, and this is for people who are going to be testing on VMs. So one of the features that you can do is use PMCs. They're advanced but very hardware specific. And unless you're running VMware, as someone pointed out, you're not going to see these registers in a VM system. You can get around it in some of these systems, like KVM with MSRs, the model-specific registers, but that's a lot of work. So the thing to consider when you're using perf is you can control who can see the perf data. So by default, there's a proc entry, as you can see, and that will limit who can see the data. So you might, by default, users cannot use this functionality. It's only administrators, someone who has privilege. But you can actually control that and set it at different levels. So basically, for people who want to start, I would encourage people to do this even now alongside lctl, because more data is always better. So you have your basic workflow, your perf list, your perf stat, your perf record, your perf script, or a report if you want. So the difference between perf report and script is one is ncursor based for those people who like ncurses. And of course, you should become more familiar with other utilities besides that. So this kind of stuff you need to really play with before your system's on fire. Don't try to play with it while your system's on fire. It takes a little time to work with it because there's a lot of options and things. So besides perf top, you have perf stats. You have your perf lifts command that shows you what's available to look at. Software, hardware, trace points. There's different classes. And you can do perf annotate, which will show you actually a dump of your assembly code for your code. So if you want to share your perf results, so the biggest thing you're going to do is doing your perf results. So there's the magic that's done is that the debug info, has anyone ever looked at it? So there's actually a format. So in your user lib debug, you'll have your build ID, and you'll have all these hash, sh1 checksum hash info. That's your debug info, actually. So when you do like a perf archive, it will collect this data. And you can also, there's commands to list it, like build ID cache. You can rebuild your cache. You can list what's in your in the directory, that build ID. And of course, using the PowerTar, you can actually, it is possible to do your own local debugging information for your local apps. It will be stored in default in the .ddebug. So what can perf replace exactly? Well, we have strace. Strace is actually quite heavy, and actually you can actually use perf to do the same thing. It's a bit lighter. It's still heavier than rubbing the original application. One of the things that people don't often use is for lctl is the tracing option. So there is a tracing option to show you where functions enter and exit. So actually, this can be replaced with the trace command. And I give an example of showing it. Another thing is with traces, it shows the return value. So if you ever looked in the code, you'll see this macro return. You can actually do the same command with perf. You have to specify the module parameter and then what you want to return and the value, and it'll show it. And you can actually specify if it's a string or integer to print it out correctly. Other things is malloc. So Lustre has its own internal memory allocation methods to record how many, if there's any memory leaks and things like that. This infrastructure already exists in the Linux kernel. So you have different levels of how much data you want to collect. So there's perf kmem. Perf kmem will do all the kmallocs and page allocations. It is the large hammer. It covers everything. If you want more fine-grained control, you can do a perf stat or a perf record with just the trace events itself, kmalloc and kfree. Besides that, there's also perf mem. So if you want to see how the L1 caches are doing, the transmission, the branches being missed, you can actually see that with these commands. So if you want to examine it that way and see how you could optimize how you lay out the data. And then lastly, if you understand your hardware, I would recommend PM Tools by Andy Klein. It's an excellent tool, and it shows you various things like cache states and how they're transitioning. And then the goal is to do Lustre trace events, to integrate that in and replace all those debug messages. And that will allow perf to give even more detailed information from Lustre itself. So where's that work being done? It's being done under ticket LU 8980. This will hopefully this will be going into 2.11. So doing this will be when people move to 2.11 or later versions, this will have an impact on how they will be doing debugging. So instead of using just lctl, and the way the code is written, you can use lctl still into the future. It supports both backends. You'll be able to use standard tools like perf and other things like that. It is designed, so the way tracepoint works and trace events is they tend to be individual debug statements that are unique. This is a very challenge. So the way the lctl system works in Lustre when it's debugging is it's in categories, as I was discussing earlier. So I have modified lctl to actually, when it does its setting, when you do your debug settings like normal, it will actually enable trace events by categories and things like that. Yeah, so you can do that. And you can also do it by module parameters. So libcfs allows you to change this stuff. So what's the biggest hurdle to doing this? 5,000 debug messages in Lustre. So this is going to be one of the largest projects that's going to touch the code base. So that is a lot. We'll probably look at making scripts that ports this stuff. So what's the pros and cons to the developers with this? Well, the con is it's more complex to make a tracepoint event. It's not your simple C debug string. So those days are going, the simplicity and change of the simplicity though, we get things, allows us to do much more powerful things like filtering. And we can actually do things like control triggers on it and debug only when certain parameters in that function happen. There's a lot of functionality that will be added. And you can actually see how you can control the format of that. So I give an example. If you cat it in the libcf ioctl format, you will see what you can actually filter. You can reduce, by doing this filtering, you can greatly reduce the amount of debugging. So there are some things you turn on debugging, like for LNet, and It's been turned off by default for a long time, and the reason it's been turned off by default is because people were like, my logs are too big, way too big. With this, you'll be able to select a subcategory, what you're really interested in LNet. So there are other caveats when you're doing this coding. You have to be careful with also putting trace points into headers besides the trace point header itself. I found that sometimes you can get these circular dependencies in things and ordering issues. So that can be kind of tricky. The other thing is when you consider this is it's not, when you're doing tracing with these tools, is that it's not it doesn't care for inlines, it can confuse it, and there's some magic you have to do that if you want to trace it and see what's going on. There are ways to work that, and you have to be careful. Like the kernel provides a no inline, so if you set it to debug mode, it'll make these things not inline functions, and then you can properly debug it. But if it's in headers, it'll collide with other. You'll see the error that it sees this function more than once. So here's a comparison of the logs. So I have to ask, is any non-Lustre developer, and Brian, because I know Brian will know how to read this, understand what the meaning of those fields in the first logs is? Raise your hand. You're a Lustre developer. Okay, so nobody understands that, and that's but can you understand the second one? So you can see the userland utility that started it, its process ID, what core it runs on, its timestamp. The only difference you have to be careful with the debugging method that Lustre uses is the timestamps are based on the time from boot. It is not the universe, from the epoch from 1970. So you have to do an offset. But the other formats we've kept similar, so this way you know, and when you look at it, and you can see how I do the categorization of the events. So you have libcfs, the console, so it's very similar. The migration, it's familiar to you. And that's how you can group it. So when you do your perf list events, you can do libcfs, config, and then star, and you'll see all those related to that subcategory. And then, of course, I group it to what the subsystem, what the area of interest is crypto and things like that. So one of the nice handy features that you can do with this, as Dimitri showed earlier, is flame graphs. So it's an awesome tool that you can use when you have all these tracing events, and it gives you the idea of how long its time is being spent, how deep the stack is going. Is an excellent way to visualize it, and especially for things like ftrace, when you collect the data, it can be millions of pieces of data. So we're never escaping the amount of data that's coming in. So this makes it visual and easy to understand. So the next thing I want to talk about is something that's actually on the horizon that will impact people. And you need it, but it's in newer kernels. And this is the 4.4 kernels. So there's something called EPF. So one of the dirty secrets that many people don't know is the Linux kernel has a VM inside it. So when it was developed in the 90s, TCP dump, they said that part of the API is there's going to be a virtual machine, and you're going to have to create bytecode that's unique to it. So when you create your filters and use TCP dump, it actually compiles a piece of code and sends it up into the kernel to execute to filter this stuff. And you think, why would you do that? And there's benefits to this, and one of the benefits is because it's a VM and it's a sandbox, there's less security implications. If you crash your sandbox, there's no violations. There's no danger of memory leaks and things going to user space. So this is one of those interesting things. So with TCP dump, they wanted to be able to do software networks inside the kernel to test it. So someone came along and said, I want to do this idea. And then what happened is they said, oh, we can use this for anything. You can touch packets, you can define routes inside the kernel. There are actually a security package that can actually monitor files being accessed. So it's a very powerful utility. So now with newer kernels, what has happened is that in like 4.4, they start migrating the U probes, the K probes, and they're all accessed by the BPF output. You can use perf to send these bytecodes up and execute it for you. You can do stack traces. Once you get to 4.9, you can do stack traces, and everything that trace events did, you can do with this. So the things they had to do though with TCP dump, they add more registers and it's more powerful. You can do maps in there, key value stores, and that's the secret for its profiling, is that data that you're interested in is exposed through the VM and you can access that data. So, and the idea was that instead of creating non-hardware based modules, you could use this bytecode and upload it. And then, so some of the interesting impacts that it could have on us is that there's a lot of utilities. So one of the things you can do is you can do all the dynamic probing, you can do it with EPF, but the impact on performance is way less than probes. If you add a ton of probes, it's going to get heavy and it's going to weigh down your machine. You don't want to do that in production. With this, you can do it. And even better, you don't need debug info to do it. So, yeah, so it's a much lighter system. And like I said, it's a sandbox system, so if you screw up the code, it won't hurt you. The other thing that's very powerful, and this is where this exceeded, the idea of this development was to exceed dtrace. And it has, and one of the most powerful things is in the flame graphs, you can't match up kernel thread to kernel thread transitions. But with EPF, you can actually get these call graph chains and actually see how the threads are interacting in the flame graphs. And that's it.
In the coral shirt.
The question is about model-specific registers. You mentioned that MSR can be used in virtual machines. Last time then I tried to use it, VMware blocked them, and I used patched VMbox for this. Is something changed now? What kind of virtual machines you used for your testing?
What virtual machines? I don't, personally, I was told this by him, but, or somebody at developer talk. So I don't use virtual machines. I use all real hardware, me personally. I have not run into this issue, but other people have told me that this was an issue for them, the KVM.
But how MSRs helps to perf?
That I haven't explored. This is someone who gave a talk and they said this is what they did to get around this limitation, was use MS registers. I haven't tried VMs. I would have to set it up and explore this and how to do this myself.
I asked because I believe many developers used VMs, and I am at least, so I'm interested.
There is an upcoming, I am going to do a huge manual write about all this stuff and how to do it and things. This is not something, I'm not giving this talk and you're going to drop and I'm going to put it in Lustre and nobody's going to know how to use it. That is not going to happen. I have been working on notes and stuff to write a manual and put this in. And you can review, because my grammar and spelling and typing abilities are really horrendous.
Thank you very much on manual. In the meantime, are there any favorite resources you have for getting started with perf and eBPF in particular?
There's stuff online if you look. There's information. And like I said, I have a developer talk which goes over a lot of the most fundamental things you can do with perf and how to debug it and things if you're really interested in this. So this talk was more aimed at the the setup and how to collect the data, what administrators will do. I didn't want to go into like, this is how you debug it. I know some people's eyes would roll here, and I didn't want to do that to them. But if you're interested, I want to make those slides publicly available, and I will show you like tricks and things if you want to do that. And that will be in the manual. I will have a section of like separated administrative versus practical use.